So apparently we're the, between you and the receptions and everything else, but I think that this will be quite an exciting panel, and I'm glad that you've hung in with us, and hopefully we'll enlighten you on a few things associated with what's going on relative to our marketplace and how we are actually using defense and satellites to help the technology of the commercial aviation era. And I think that we have a very broad background of several different people in different parts of the different business, and so we should have different perspectives on all of that. And so I'm looking forward to the panel discussions. Who we have here is Marcus Vilaca. He's the Executive Director of Engineering and Technology Strategy from Yahsat. Marcus is responsible for the future systems and technology strategy. He has over 35 years of experience in the satellite industry and is presently Executive Director, Engineering Technology Strategy at Yahsat. Welcome, Marcus. In addition, we have Eric Beranger, who's the Head of Programs for Space Systems, Airbus, Defense and Space. Eric was appointed the CEO of Astrium Services at its creation in 2003. Under his leadership, the company has grown its revenues and workforce more than 15-fold between 2003 and 2012. He achieved major successes in contracts including Skynet 5, Satcom BW, Yahsat, and at the end of 2011, the acquisition of Vilaca. In October of 2012, Eric was appointed CEO of the first satellite manufacturer in Europe, formerly known as Astrium, now known as Airbus Satellites, which is the #3 satellite company in the world and the second in the world in space equipment supplier. Please welcome Eric Beranger as well. Third is we have Andy Sukawaty, the Executive Chairman of Inmarsat. Andy is the Executive Chairman of Inmarsat PLC, having been the Chairman and CEO since 2003. He led the company through its privatization and listing on the London Stock Exchange. Inmarsat has grown its revenues and profits dramatically in this period. Andy has over 35 years of experience in the communication services arena, including wireless cable TV and satellite, and is a pioneer in the mobile communications. He has led 4 IPOs in both Europe and the United States. Finally, we have Paolo Carmassi, the President of Aerospace, EMEAI, Honeywell Aerospace in Switzerland. Paolo was named the President of Honeywell Aerospace in August 2006. In this capacity, he is responsible for driving profitable growth across the commercial and defense business segments, strengthening customer relations, driving operational performance, and establishing Honeywell Aerospace as a domestic player in the region. His diverse background includes leadership positions in engineering, sales, product management, marketing, general management, as well as a broad scope of international exposure achieved in 2 decades spent living in 6 countries and 3 continents. So quite a diverse panel, and looking forward to the discussion. What I've asked the panel to do is to provide some opening remarks in regards to our panel and the topic in general. And then after that, we'll be asking specific questions. Clearly one that I know that you want Andy to answer is relative to what's going on with Malaysia MH370 and how was Inmarsat part of that. Actually, there was many people on the panel that are a bit associated with it in one way or the other, so we might have a little discussion on that. But right now, I'd like for general comments, and Marcus, would you like to start it off?
Sure, Jim. Thanks. First, it's a pleasure to be here. I think that's a very interesting panel. I personally am a great believer in the use of satellite technology for communications for airplanes. I think that's something that has been provided for quite some time, but only now we are beginning to see it really taking off. And certainly one important part of it is to flow developments that were done for defense satellites, for things like WGS or CCRAW and other satellites, use that for commercial satellites. But I also think that developments that we see for UAV terminals and for other types of aeronautical defense type of terminals will eventually flow into the commercial area, giving us more capabilities and benefiting from research and development that were done in other areas. I think the timing is very good for this panel, and I'm looking forward to the questions. Thank you.
Thank you, Marcus. Eric.
Good evening, everybody. So, as well, it's really a pleasure to be with you this evening. As you may guess, Airbus takes a genuine interest in this topic, given the range of activities that we have in this value chain from the aircraft manufacturing to the space technologies that we master. We manufacture satellites, of course, but we also create the connectivity. We run the services, since we are one of the first providers in the world of mobility services, especially for maritime and as well for aviation. The topic this evening, I think, is extremely key for us, because first, it's a developing business. Today, connectivity, airline connectivity, aviation connectivity, sorry, it's more than $1 billion in terms of turnover on a yearly basis. On the narrowband side, I've read some forecasts showing that in the next 10 years, it's believed to grow with a CAGR of something like 6%. On the broadband, we are more above the 15%, 16, 17%. So we see that it is really a growing business. It's very strange. So from a business perspective, absolutely key. For the aviation community, we see that each airline is trying to differentiate itself. And of course, the permanent connectivity is a key enabler to this differentiation. From a service point of view, I hope we will debate it this evening. Connectivity is, of course, a key service for aviation, but there are many more, such as, I don't know, weather forecast, traffic management, tracking, plenty of things. And we are in all of this. So really a key topic, topical indeed, unfortunately, but an absolute key topic to the development both of the aviation business and as well to mobility, because here what we are talking about is in fact total mobility, including in the air.
Thank you, Eric. Andy?
Yeah. Thank you, Jim. And I want to thank Mubadala for sponsoring this very special event. We appreciate you hosting us today. I guess a couple things to say on this topic. We've been a satellite operator for 34 years. We were created originally to serve safety at sea, which started with maritime and then moved into aviation. We've been providing aviation safety services for 20 years. If you look at the percentage of our revenues that come from government customers, it's about 45% of our revenues today, and about half of that is defense. Historically, the government percentage and defense percentage was larger. So you could argue we are sort of an illustration of defense spending helping to fund the development of commercial services, just in purely funding the satellites and the operating services themselves. So that, I think, is just apparent in the numbers. But it goes beyond that, because of course the technologies we choose are often funded in terms of the research development and the non-recurring charges by often the big defense customers and the big government customers. So we ride in the wake of that and have for 3 generations of satellites, with now 3 generations, well, 2 generations in the sky, a 4th generation going up. We are in a position of taking the different technology choices and trying to apply them in a commercial context. And the best example of that I can draw right now is a new constellation we're launching. It's a Ka-band constellation called Global Express. It looks very much like the WGS satellites being used by the US DoD, but these are satellites made by Boeing, and they really go a step further in taking these high-capacity Ka satellites, using steerable beams and increasing the coverage dramatically, because we think the maritime base of customers and aviation base of customers will find that appealing for a mobile global satellite service. So I think it's an example of how that development of those specific technologies around that can now be used in the commercial and aviation sector.
Thank you, Andy. Yeah, blurring the lines between the commercial and the government applications seems to be more and more a trend. Paolo.
Yep. Very pleased to be here. Thank you for the opportunity. Honeywell, I would say, represent an element of the value chain that all these companies have been trying to build over the years. Clearly, as Andy said, we also benefit from the momentum that the defense industry for many decades has provided in terms of leading the technology and providing that critical mass. Today, we enter into an era where the satellite communications unlock opportunities on the civilian market that could have the same momentum and the same emphasis that in the past was only reserved to a major defense program. We've been operating on satellites and communication across the spectrum of the aerospace, both the civilian air transportation, also the business jet, the helicopters, both on the ground, in the air, and on the satellites. And we really look forward to this positive juncture where certain technologies only 10 years ago were not in place to enable the sort of breakthrough that we're talking about today, where high-speed connectivity becomes available. And all of a sudden, we talk about a very excited audience, not only in the cockpit of an aircraft, but also in the back of an aircraft, on the ground, in the air traffic management, where we see the opportunities for all this technology to come together in a way that is unprecedented. The intent being duplicating that same experience that more and more people are having every day in a more connected home or in a more connected car. Now this same experience crosses the door of an aircraft, and the expectations, again, both on the front in the cockpit as well as in the back of an airplane, is to have that seamless experience, and we're very proud to be part of this story and being able to provide these technologies and these solutions.
Thank you, Paolo. So the first question I'm going to ask is, they've often said timing is everything. And a little over a decade ago, there was connection by Boeing that was supposed to connect the aerial layer to the commercial airplane industry to be able to provide internet in the sky. What now, 10 years later, has happened such that it is now time for this type of a program to be reevaluated and to be applied more generally? And I'll open up to the audience. Eric.
Yeah. I think lots has evolved over the last 10 years. In this type of forum, very often we look first at technology, so let's look at technology first. I think that we have today capabilities which were much more capacitive. We are able to deliver much more capacity to our mobiles. We have on top of it, up there in orbit, the capability to put satellites which are much more flexible, meaning really directing the power and the communications where they are needed, and so much more adaptive. So at the end of the day, we are allowing much more capabilities inside the aircraft. This is now available, and this is improving on a really continuous basis. But of course, technology is not everything. You must have as well the right price point. And here as well, I think we have more competition. It's too bad for some of the players on this panel, of course, but we have more competition, I think, than in the past years coming up. with new bands being used, especially KU and KA. And this helps, I think, taking the prices down, since now we are forecasting going to something like $1 per megabyte to less than 10 cents a megabyte. This is a major, major difference. But all of this would be totally useless if there was no demand. And I think that on the side of demand, there's been a huge evolution over the last 10 years. Nowadays, everybody has a tablet, everybody has an iPhone or whatever. And everybody, especially the young generation, cannot stand not being connected anymore. Everybody wants to be connected permanently without caring about where they are. They want the same data rate, they want Wi-Fi, they want broadband, they want TV, they want internet, they want to chat, they want everything. And this is what we're talking about today. We're talking about permanent connectivity wherever you are. And we have today, I think, the congruence of this demand, and on the other side, the technological capabilities and the competition which are giving access to all those capabilities at the right prices. So I think this is the big change.
Anyone else?
Yes.
Go ahead.
Well, I think Eric covered a lot of territory there, and he said it well. I would only add to that the customer experience itself on particularly long-haul flights is changing, and the customers are demanding this connectivity because it's become such a piece of their lives, not only in business, but their personal lives. And as much as some of the surveys tried to say, well, people don't want this, I think the data is starting to show that, in fact, people are using it and want it and will pay for it. And I think the who will pay for it model is still in flux, but I do think there's clear demand there, and that's by usage figures that come out of people like GoGo, air-to-ground system, but also some of the experiences of Emirates and Etihad themselves, who've clearly been pioneers in this area. And I think you're seeing other airlines in the world now stand up and take notice. There's a huge number of RFPs out there. Of course, we are on 10,000 aircrafts, commercial aircraft, virtually every commercial aircraft that flies over a blue ocean for safety services. And that, as I said earlier, is 20 years been there. I think we're now talking, though, broadband connectivity, which is a complete different game. And it's one of the major reasons we're putting up this new global GX constellation, which we think is the first constellation that will give seamless global and true global coverage for these kinds of applications. And we know from the maritime industry and serving the aviation industry for many years that they need the flexibility that goes with global, because it's very difficult once customers start using it and become dependent on it to say, well, I've got a gap and it's going to stop now. And so that's been something we made a commitment to of $1.7 billion 4 years ago, and by the end of this year, we'll have that full constellation up and begin offering global service. So you talked about timing to kick this off. I think it was unfortunate for your company, Jim, to talk about connections, but times have changed, and I think technologies and the customers have changed.
I would add to that obviously there is now a much more mature audience that is willing to use these services. At the same time, I would say as an industry, we're facing a challenge that these new users bring a consumer electronic experience, right, which the aerospace doesn't necessarily match. And I would say it's not necessarily that it's consumer electronics components, but most of the technology are transparent to these millions of users that take that experience with, whether it's an Xbox or a YouTube or whatever, and they will expect the continuity that Andy was talking about, and we are proud of partnering with Inmarsat on the Global Express to provide a seamless connectivity. But I think as an industry we will continue to be pushed, because that's not a destination. I suspect that will be probably the first feasibility example that will create even more appetite, and so will force this industry, where this industry has been its best, keep pushing the boundaries of the technology, just at a pace that is probably unprecedented for this industry. So we look forward to that.
Along the same lines of this is, do you see that the emergence of these types of new satellites, these new high throughput satellites, as obsoleting some of the current systems that we have with the narrowband technologies for a lot of the mobile communications going forward? Do we see that evolution happening, or do we see a complementary type of an approach for, can these systems live together compatibly, or is one going to supersede the other?
I think you'll get varying opinions on that based on your position in the marketplace, I guess. It is clear that the high-capacity payload satellites and the new higher-powered satellites allow you to deliver a bit more cheaply. And Eric, again, I think correctly characterized that. It's not a little bit cheaper, it's very much cheaper. And Marcus, I think, can probably comment to the fact that that's being technology driven. It's also driven by the amount of spectrum available at these higher bands, so that we can actually drive higher throughput, higher speeds, and lower cost.
Marcus, you want to comment?
Yeah, and I think that Andy picked on the right point, is because on the previous discussion, Eric, I think, mentioned the reasons why things have changed so much from connections, like the demand was not there. But not only the demand was not there, but in fact the systems were not able to provide the throughput that would be required even if the demand was. And with the use of higher bands like K-band, we now can provide a much lower cost per bit, but we can also provide a huge amount of bandwidth, because I think that is also, in my mind, one of the very significant difference from what has to be done to support this market. Because I see the planes much closer to the cruise liners than they are to the normal, to just a ship on the Atlantic, that has only the crew using it. We have to provide much lower cost points, and I believe that it has to be even below the 10 cents per megabyte. I think that users will expect something closer to what they get on the mobile phone plan, which is closer to 1 cent per megabyte. But we also have to be able to provide a much higher throughput, and that can be achieved with the higher bandwidth that we can offer, with the higher gains that we get on the satellite with smaller beams. And also, not to be overlooked, is this very significant progress that we saw over the last 10 years or so on the modulation coding techniques that allowed us to do this in a more efficient way. And I think that in terms of the coexistence of the narrowband and the wideband systems, I believe that they will coexist. I think that narrowband systems using lower bands like L-band have advantages when you are interested in higher resilience, and that where the absolute throughput is not that important to you. So if you're just transmitting some location information like GPS, you don't really need a lot of bandwidth, but you'd like that data to be transmitted very reliably. And in that case, and depending on the application, L-band will always be a very good solution.
Thank you. So segueing to location, one of the things that's been in the news quite a bit and has been talked about is the Malaysia MH370 aircraft and its crash. I'm going on a limb, it crashed. I don't think it's been confirmed, but I'm pretty sure it has. But part of it was the actual, at least a surprise to many, as that why we couldn't be able to locate this satellite, this airplane quicker. And what we did find, though, was that through the use of satellites that we were able to do many things to be able to find the airplane, find its location, at least to a point, and really help in the search. And I know that Inmarsat and others were quite involved in it, and I was wondering if, Andy, you could comment on it a bit.
Yes, I mean, first thing you always have to start with in this situation is this is a great human tragedy, and there's a real urgent requirement to locate this aircraft, and so it's sort of all hands on deck, and we play a small part in that and trying to see what we can do to locate this and identify what exactly happened. So, we were a communications link on that aircraft that existed even after the communications links and transponders were shut off. We're on 10,000 aircraft, as I said earlier, for safety services. But you have to be clear, in this instance, there was no SOS signal, there was no signal sent. There was a safety service. In fact, the ACARS system was shut off and there was nothing sent. The only thing that existed was the terminal had power going to it. And this was an Inmarsat classic terminal made by Honeywell. And that terminal sits there and gets called on periodically so that we know that there's terminals in that general sector so that we can assign radio spectrum to it. And that's quite important for safety services because if there isn't spectrum when you go to use it and power, then you've got a problem. And we have to instantaneously react. In fact, our safety services, both at maritime and aviation, are regulated. In fact, once a month we submit a report to the International Maritime Organization, which actually also goes to ICAO, saying we've met this reliability standard. That's fundamental to safety services. So they had the terminal. It was getting pinged, as they've said in the press. We reported that in a very timely manner. Our customer was SETA, who was providing the service to Air Malaysia, Malaysian Air. And I can't say a lot because subsequent to that, we were appointed to the group that is investigating what happened. And that is a very tightly held set of data that they have, not only from us, but from many others, and we provide the data to support that. Now, some of it is public, so I can talk about it. Certainly, we provided data very quickly as to the fact that the terminal was transmitting well beyond the time they lost communications to it, so approximately 7 hours after that. In addition, we followed that with data which indicated, based on what we could see from the one satellite that was getting the ping, what the arc was, where it must have been, based on the last ping. And the series of pings, actually. And then the third bit of data that was provided is our engineers and scientists, along with collaboration with some of our vendors and support, looked at what else we could provide that wasn't standard. And we realized that this particular satellite is on an inclined orbital path, meaning it's moving back and forth across the equator. And based on that, we could look at the Doppler effect, which hadn't really been done before with an inclined orbit satellite. And based on that, we could determine in this arc whether it was the northern or the southern route. So I'm sure you've seen all this appear in the press, so none of this is news, which is why I can talk about it. It shows, I think, though, the importance of connectivity. Now, in the last 2 weeks, Tony Tyler, who is the Secretary General of the International Air Transport Association, gave a speech where he said, what should we take from this right now? And I think there are two targets. One is that this data that is either sent for safety reasons or is sent as an alternative to the black box probably needs to contain flight tracking. And secondly, improvements have to come on passenger data as well, which I won't speak to, but what both the International Air Transport Association as well as ICAO have announced is that they've created an expert task force that will report by December of this year on what should be done about this to now more urgently address it, because sometimes it takes a catalyst like this to get the world moving. We all know that after September 11th, the door to the cockpit on aircraft almost universally got upgraded, and that was the catalyst that drove it. We hope, because I think it's a fairly simple thing, to add location data to what's being transmitted on these aircraft. The transmission path is there. There is a safety system on these aircraft, so there's no reason why this can't be transmitted other than we have to agree to a standard and how it'll be reported and what the conventions will be. And I think that now needs to happen.
Well, thanks, Andy. Along those lines of what happened with the Malaysia aircraft, obviously our topic is how does defense and satellites help in commercial aviation? What are we seeing, if any, impediments by governments to enable that type of technology to be applied to commercial aviation, if any?
If I may, I think it's not so much an impediment by governments. It's more a matter of standardization, because by its very nature, commercial aviation cannot be bound to national boundaries for operating procedures, and so then it comes to standardization, being able to use certain services, to operate certain services with a worldwide coverage on all airlines with multiple devices, and so it comes to standardization. And well, civil aviation is known not to be extremely quick in standardization. I think it's not the fastest area of the world. But there's been quite a lot of progress in the recent years, be it for the standardization of the L-band or Ku and Ka-band antennas on board the aircrafts, the so-called ACARS 781 and ACARS 791, if memory serves me well, which today are factored in upfront in the design of the aircrafts. This is what is done today for the F-350, for instance. And as far as security is concerned, here as well, there is today a lot of efforts to move it forward. Here in the States, there is this next gen initiative, which I think is extremely important. You have the CESAR initiative in Europe, and all of this as well are initiatives to move forward the standards, and it takes time, this is true, but there's already quite a lot of progress, I think.
Yeah. To build on what Eric was saying, obstacle will always be there. It's important that we keep the eyes on the prize here. A more connected aircraft, unlike previous attempt 10 years ago when the technology was not ready. Today, if we look at what's possible, what would be possible, let's say from a cockpit point of view, whereby at every given minute there are thousands of aircrafts, thousands of weather radars, thousands of central maintenance computers flying at every moment and collecting what I believe is a half a tera data per flight. So we're talking about the subject of Internet of Things that other industries have already embraced. We as an industry have to learn and find ways to extract values. At Honeywell, with our technology, we look at ways to integrate the 1,000 weather radars that at every given moment are flying, and to provide, for example, pilots not only with the tactical view that they can extract from their own weather radars, but there are likely to be 10 aircrafts ahead of them flying the same route they will fly in 20 minutes, in half an hour, in 2 hours, in 10 hours. And being able to put all these together, not data for sake of data, but find ways to extract information for the pilots is an example. People often refer to also the maintenance that can be done by harvesting all these informations, and I think there as well there's an opportunity to use and learn what other industries have done, again in our home, in our cars, why not in the air, and being able to use all these informations to improve the safety of flight, the efficiency. This morning we were following a panel, airlines average profitability is 0.5%. I mean, this is a $500 billion industry that in a good year, 0.5% is very, so bring that efficiency, that productivity, that safety, that wealth of information that the pilots, 30 years ago we had 3 pilots in a cockpit. Flight management system has been introduced. We had 2 pilots in the cockpit. Maybe tomorrow, with this information available, we may have 1 pilot in the cockpit and 1 pilot on the ground supporting each other. And maybe in some cargo activities, we may not have a pilot. I suspect in the passenger flights, we'll always have someone walking to the cockpit for the confidence of the participants. This is what's possible, and that's where the barriers will become just barriers that need to be knocked down.
Maybe one addition to this, if I may. Here we are talking very much about the connectivity and the way this connectivity is enabling the sharing of information. And then it takes us to even the world of big data,
Yeah.
how to manage, how to extract this information. But space is also a provider of information itself. Space is not only providing connectivity, but space can bring information to the cockpit and to the airlines. I would take only two examples. Take the navigation systems. Thanks to those navigation data, then you can indeed support the cockpit and enhance the cockpit capabilities. But also space can bring a lot of information, not only on the weather, but also on the cartography of the winds, depending on the altitude, which can bring a lot of very valuable data for the navigation and at the end of the day for the environment and the consumption of fuel. So there are many areas, and I will stop with those two examples. There would be others, but there are many areas where space does not bring only connectivity but also information.
Andy?
I mean, there has been an impediment that I think is overstated, but it also needs to be clarified. I mean, if you go to big data or you go to some of the applications that have been talked about, they take bigger and bigger packets of data, bigger and bigger messages, and you have to draw the line as to where you want to go. I mean, ACARs and safety services are a line as to where you want to go in cockpit data. I think the big question on the table now is, what subset of what's going to that black box should be going into some kind of regularly polled set of information that goes out? And we think at a minimum that should be location. We think there's a minimum additional set on aircraft health. And we think that can be done about every 10 to 15 minutes for no more than $7 to $10 per 5-hour flight. So it's not a transmission cost issue, and it's in terms of what we're looking at today with this disaster. That can be done. It can be done quickly, straightforwardly, with not much expense on the aircraft today and not much transmission costs. But I think there are many other things that can be done to improve the productivity of the airline, improve the safety, improve the performance of the aircraft that goes beyond what you're seeing from ACARs today, and I think that's what's being referred to as well.
If I could right now, we've got a few minutes left. Could I, if anybody in the audience would have a question? Yes.
Good afternoon. My name is Oliver Joyce. I'm coming from France. It's a question for Mr. Beranger regarding the services. Your point was you're focusing mostly on the services. The business will come from the services. Do you think the revenue will come from the onboard services? I mean, will we make money out of the passengers, or will we make more money with the operational efficiency that those services will enable in the future? I mean, will we reach higher savings, or will we make revenues from the passengers? What's your feeling on that?
So I'm not the only one relevant for this question, but I can start. My very strong belief is that the business model has to find a way to extract revenues from the passengers, because the cockpit and the operations alone, I think, are not enough to fund such systems. Now, it is true that today, as Andy was saying, I don't remember the expression you used, Andy, but the business case is still a little bit in a flux, because today there are already services which are existing, but to my knowledge, they are not profitable today. So it's still something which needs adjustment. But we see the flux, we see the capabilities, and we see the demand. So it will have to come one way or the other.
I would echo that answer clearly. On the savings in the cockpit side, we believe that as long as fuel remains 30-40% of the operating cost of an airlines, a 1% savings covers a lot of costs and opportunity there. But to your point, the critical mass of what you can do with a large capacity and where the value will actually be extracted, that will be an interesting game to watch in the coming years.
Well, I think we've been saying for a long time, the big question that's been holding this up is who's going to pay? Is it the passenger? Is it the airline? Is it the in-flight entertainment company? Is it some mixture of those things? And I guess the one thing I would say to those that are with the airlines here is there is no free lunch. So if someone that provides in-flight entertainment is giving you a free connection, you're going to pay for that connection somehow because they're paying for that connection. If someone's giving you hardware, well, it may look good up front, but somehow that hardware has to get paid for. So it's I don't know if it's a zero-sum game, but you know, you have the transmission cost, you have the hardware costs, you have the maintenance costs, and then you have the services costs. And I think what we're focused on is trying to work with our service provider partners, of which Honeywell is one, to provide a seamless service, but we're focused on the connection and having people that add value in these other areas add value where they add value. And that's the way we've approached the market. Others have approached it differently. So I think you're going to see this play out in the years ahead, and it's a bit of a confused state right now.
So we've officially ran out of time. I know there's multiple things that we could, go ahead. We're going to get more time.
That I'm actually going to wrap up the session.
Oh,
Maybe
okay.
I could just extend it for 2 minutes because I'd like to pick up on what Andrew has said, Nick Gowing. I was very struck in the Malaysian incident how they set up a working body, a working group, which was including you and Boeing and many other groups, including the Chinese. And when I heard that, I said to myself, security, classification, and so on. How much in this developing business are you able to share, given that this is for the benefit of commercial aviation? And how much are the marginal secure issues likely to limit the possibility for sharing of that information? And we sort of have a very interesting example. I'm tempted to use the phrase Chinese walls, but you know what I mean,
Yep.
I think. It's been fascinating just who's been detecting a ping somewhere in the southern Indian Ocean, but about what you can share in this new environment and what remains both commercially and secure for sovereign reasons as well.
It's an excellent question, and I think we're clear that our customer was SITA, and SITA provided this to Malaysian Air, and we have no authorization to give any data to anyone else other than them. Now, when this panel is created, and we get the releases as a result of the panel being created in the investigation from SITA, who becomes part of the panel as well, and the customer, Malaysian Air, then we get to a point where we can disclose fully all the detailed data to the parties that are brought in by government and the investigation panel in that situation. And that's exactly what happened here. That played out over about a week to 10 days. And that, I think, rightfully and fortunately brought the Chinese and many other, let's say, parties that could add to the situation into the picture, all contributing where they could contribute and also representing their interests where they could represent their interests. We're simply a data provider, and I'm sure we're one of many to that process, but we have to have the right authorizations because we just can't, on a private transaction, be releasing information to people.
The reason I'm asking that, James, on a broad issue of
Right.
the advantage of commercial aviation, what potential is there, but also what are the limits there for all of you in the satellite business when it comes to sharing information for the benefit of those who are flying and every airline that's flying? At the same time, you're facing a commercial competitor, which eventually will be the Chinese.
I'll just speak is in these kind of situations, there really isn't, I'll say, competitive positioning on these. I think that the key is to get the appropriate data in the appropriate channels to make the appropriate decisions for these types of issues. And in that case, there is traditionally a lot of international cooperation associated with that.
Yeah.
Yes, there's always competitive nature, but in these kind of situations, the issues are really more of how can we provide the appropriate data to solve the problem. And I'll just say that there's been a lot of cooperation, and I'll leave it at that.
Yes. And you mentioned the Chinese in this context. In December, we just opened a new land Earth station in China that was funded by the Chinese and owned by the Chinese. And each country has its own laws relative to the traffic in its country that apply. And every operator, not just us, has to comply with those laws. And then when that is set up and there's a contract between us and the customer, whether that customer is a distributor and that distributor sells to an airline or someone else, that becomes sort of the rule of law for us. And that's the way we play it globally, or we couldn't be an international player. And I think we're licensed actually for aviation services in more countries than anyone else.
Well, if I may wrap it up a bit, is that, first of all, thank you very much to the entire panel for a very fascinating discussion. We could probably go on for another hour talking about air traffic management, drones, UAVs, and other things. Clearly, though, the line cut off. Now, clearly the lines between commercial and government have been blurred, and you're seeing it more and more, and hence why you're seeing the evolution that we're seeing in the commercial industry. And I want to thank everybody for their time for this. Thank you.
Thank you, James.